Rolle's theorem, we got the definition right here in front of us. Rolle's theorem says that let f be a continuous function on the closed interval from a to b, notice the brackets for closed interval, and differentiable in the open interval, in parentheses denoting a comma b. Okay, so in this case, remember, it doesn't need to be differentiable at the endpoints. Endpoints, you can't really be differentiable because you have that situation where you draw an infinite number of tangent lines there, or no tangent lines, whatever you want to consider that. Well, this states that if you are continuous on the closed interval, in other words, it goes from point A to point B smoothly, and differentiable in the open interval from A to B, that if the function value at A is equal to the function value at B, you are then guaranteed at least one number C in AB such that f prime of C equals 0. So let's look at that visually. We'll call that A. So here's A. So that means this is going to be f of A. Here's our x-axis. Here's our y-axis. And let's say here's a B value. B value. And this is not only f of A, but it's also f of B, right? Isn't that what the theorem states? F of A equals f of B. So if I plug in A, I get blah. When I plug in B, I get the exact same blah. Blah. Dracula. Blah. So let's think about how many ways I can get here continuously. I could go wee, right? Like a little sine curve, kind of. Well, f prime of C would equal 0 at the top and at the bottom. I could do just a boring old parabola, upside down or right side up. In both cases, we have a derivative equal to 0. So let's just do that. Okay, we're guaranteed at least one number. Well, in this case, I have horizontal tangent line there and a horizontal tangent line there, occurring at two different values. Let's call them C sub 1 and C sub 2. So what this is stating is that if you have two x values that give you the exact same y value, you are guaranteed somewhere in between those x values to have a derivative equal to 0. Why is it important to have a derivative equal to 0? Well, that's a critical value. And critical values are where we find relative extrema and absolute extrema. So let's take an example here. Let's take f of x equal to, let's just take a boring old x squared minus 3x plus 2, boring old quadratic. Well, quadratics, you guys spent tons of time in the algebra classes, algebra 1, algebra 2, solving them for their zeros and their roots. We've even done some of that last year in trig, for those of you who remember, finding the zeros there. So let's look at this guy, and let's factor it, x minus 2, x minus 1. So when x equals 1 and x equals 2, we know that f of x is 0. Therefore, between 1 and 2, there exists a C value such that f prime of C equals 0. Okay, you are guaranteed for that to be true. Okay, and to find that, you guys know how to do that. Simply take the derivative set equal to 0. All right, f prime of x equals 2x minus 3. When does that equal 0? Well, that equals 0 when x equals 3 halves. And sure enough, 3 halves is between 1 and 2. Okay, so that is Rolle's theorem showing you, stating the existence of a derivative equal to 0 when you're between two x values that result in the exact same y value. Okay, and again, deals with continuity on that closed interval and differentiability on the open interval. That is Rolle's theorem for you. We'll show applications of that a little later. We have to talk about the mean value theorem here shortly. Have a nice one.